So a little change in the story, because this method is also worth learning, because this method works for the positive mod as well. So it's not limited to the negative story. If your idea is clear about how these graphs are operating with each other or working with each other, and the final output is a result of these two graphs, then you can use it in any story. So again, let me follow the same story. The mods are still exactly the same. Beyond 5, this line is going up, this line is also going up. The slope for this line is +1. I can see it as I'm increasing x, y is also going up. The slope for this line is also +1, right? I clearly understand that. But this time there is a +1 in the story. What does that mean? This will go up by 1, this will also go up by 1. Say the story, the value was A here, say the value was B. If I go from 5 to 6, what is going to happen to A? A will become A plus 1. B will become B plus 1. Why the plus 1? Because I'm changing x by 1 unit. Both of them will change by 1 unit. The slope is 1. If the slope was 2, I'll change it by 2. Not too much of a difference there, right? And in this time, I have to find the sum, because the overall story is add gx and hx, right? Two functions. So that means I have to add them. So what is the new value going to be? A plus B plus 2. So here at this point, if the value was A plus B, at the very next point, the overall value of the new function that I'm drawing in black will be A plus B plus 2. That means for a unit change in my final graph, the slope is 2. Actually, just to be technically clear, I should make it steeper than the other graphs, right? So I have a new story, and the new point is going to be A plus B plus 2, which I got from here. And the overall slope for the new graph has become 2. Why? +1 and all of them are getting added. Why was it constant in the previous story? Because +1 and a +1, but they were getting subtracted. So it was getting cancelled out, the new parts, and the old part continued. That's why the same line, right? The same thing I can apply here. What is going to happen beyond these points? What is going to happen beyond 3? This line is going up. This line is also going up. Okay, let's be theoretically correct. This line is also going down. This line is also going down. Right? Beyond 3, I'm thinking, extended these lines. See them here, action. So they are both coming down. That means the overall slope will not be -1, it will be -2, because they are getting added together and there is a plus sign in between, right? So get that idea going. What is going to happen between and 3? One line is going up and one line is going down. You will see that between 3 and 5, the value of the function will remain the same. Why is that? Because you are adding, there is a plus sign between the two functions. But one function is increasing by 1 and the other is decreasing by 1. So it will cancel each other out, right? That means say the value here was A and the value here was B, and you're finding the value as A plus B at this point, at x is equal to 3. If you go to x is equal to 4, what is going to happen? Instead of A, you will get this graph is going down, you will get a minus 1. But instead of a B, you will get a B plus 1. And you're adding them. The -1 plus 1 will get cancelled and you will still get a plus B. That means at 3, whatever the value was, it will remain the same as at 4 and it will remain the same at 5. Beyond 5, it will go at a slope of 2. Beyond 3, the new function you will create will also have a slope of 2 in the other direction. Or you can think of it as a slope of -2. So can I apply the same shortcut with the plus sign in between? For this we have multiple other methods we have already looked at, but this graph method can be very, very elegant and can really create that aha moment in your inventory, right? First of all, plot the points 3 and 5. Find out the value at 5 and find out the value of at 3, right? That's what we want to do. At 5, this will become 0. 5 minus 3 will give me a 2. Plot the point. This point is going to be 5, 2. I look at the story. Slope is 1. Slope is 1. The slopes are getting added. That means beyond this point, the slope is going to be 2. Why is that? Because this time I'm adding the slopes. Okay. What is my task now? My task is to find at what value of x does this become equal to 12. So let me stick to this story. I know at x is equal to 5, y is equal to 2. Y is equal to 2 and I want y to become 12. So I'm going from 2 to 12. There is a change of plus 10. There is a change of plus 10. The slope is 2. What does that mean? For a unit change in x, there will be double change in y. So if you want a change of 10 in y, you want a change of 5 in x. So 5 plus 5, x will become equal to 10. Check your calculations, and 10 minus 3 will give me a 7, and 10 minus 5 will give me a 5, and a 7 plus 5 will give you a 12. Run the same story on the other side. So you notice that the method will work exactly the same. So it's worth spending 15-20 minutes, half an hour extra, one sitting extra to really master it, right? Because finally you have to take responsibility. 3 minus 3 0. 3 minus 5, I get a minus 2. Mod of that will be a 2. At 3 also the value is going to be 2. So I also noticed this earlier, that the value between the 2 points was going to be a constant. Quickly look at y. You had this graph and this graph. Between these 2 points, one was going up, the other was going down. The slopes were cancelling each other out. So whatever the value is constant, right? Again, I want to go to 12. Again, the story will go in this direction and the slope will be 2. If you're thinking like that, if you're thinking in pure algebra, the slope is minus 2. But it doesn't matter too much. I know at x is equal to 3, y is equal to 2. I want to go to y is equal to 12. The difference is 10. So to create 10 steps in y, I have to go 5 steps in y. That is the meaning of slope, right? 5 steps in which direction? Obviously not in this direction. I'm thinking in this direction. So 5 steps in this direction, x will come out as minus 2. So this is just a demo that this story works for the plus sign also. Maybe the method, the distance method story might not be very effective. Maybe go back to those examples, those exercises, and now try them again using the form, the graphical form, that you know what is happening to the slope, you know what is going to happen beyond, you know, now you also know what is going to happen in the middle. We started off the shortcut as like a sasta shortcut, okay, what is happening beyond the ranges only, but now we know that most importantly we have learned, if you followed the whole journey, you've learned to figure it out by yourself. Okay, somebody has pointed it out, let me also play with the game. Take half an hour out from your busy life and derive all of these things by yourself, play with them, right?